Let's explore a geometric figure that, although it seems simple, holds a profound meaning across cultures and through time, the Dodecagon, whose very structure makes it a powerful symbol of order, balance, and totality. The number 12 has a strong symbolic value in various cultures. It represents the 12 months of the year, the 12 signs of the zodiac, the 12 divisions of time in the clock, and more. In the religious and spiritual realm, it appears as a number of fullness and the closing of cycles. We find it again and again. The 12 apostles in Christianity, the 12 tribes of Israel, the 12 imams in Shia Islam, and even the 12 Olympian gods in Greek mythology. Geometrically, the Dodecagon is related to three fundamental figures: the equilateral triangle, the square, and the hexagon. By dividing it radially from its center, we can regroup its sections to obtain these three basic shapes. In art and architecture, its presence is equally strong. The Gothic rose windows that filter light into 12 parts, the Buddhist mandalas with their radiating symmetry, and the Islamic mosaics that multiply symmetry from a perfect dodecagon. The Dodecagon, then, is not just a geometric figure. It is a symbol of cosmic harmony, of the union between mathematics, art, and spirituality. By learning to construct it with a ruler and a compass, we not only acquire a technique, but also connect with an ancient tradition that has long seen in geometry a reflection of the universe. In this tutorial, we will learn step by step how to construct it with simple geometric tools. Let's begin. We will draw a horizontal line and mark the length of the segment that we will use for our drawing. Next, we will draw a vertical line that divides the segment into two equal parts. To do this, use the compass to measure this segment and, from one end, draw an arc above and below the horizontal line. From the opposite end, repeat the same operation. The intersection points of the arcs give us the reference to draw the vertical line, which will pass perfectly perpendicular and divide the segment into two equal parts. We will keep the same compass opening throughout the entire drawing process. Then, we place the compass point at the center, where the lines we already have intersect, to draw an arc like the one you see. Let's first look at what we have. There are 4 quadrants, so if we divide each quadrant into 3 equal portions, we will have the 12 spaces we need. Trisecting or dividing an angle into 3 equal parts using only a ruler and compass is a fairly simple process. It only has one exception or condition. Not every angle can be divided. Only angles of 45 degrees, 90 degrees, and 180 degrees can be divided. The arc we have drawn measures 90 degrees, so it can indeed be divided. Keeping the same compass opening, we place the compass point where the arc intersects the horizontal line and draw a small arc where it crosses the large arc. We repeat the same operation from the upper intersection as shown and mark the new crossing point with the large arc. Thus, we already have the arc divided into 3 parts. To make the crossing point more precise, I have marked it with a small line. We repeat this division process in the adjacent quadrant. Once this is done, we proceed to draw the lines that pass through the marks we have made and through the central point, extending them toward the opposite quadrant. We now have the 12 dividing lines that allow us to draw the regular 12-sided polygon, or dodecagon. By joining each intersection around the circumference, we will make a circle that marks the limits of our figure. You can make it smaller or larger. It doesn't matter. But before drawing the regular 12-sided polygon, we will draw the equilateral triangles resulting from joining only the points that divide the circle into thirds every 4 spaces. By doing this radially, you will see that by drawing 4 triangles, the circle is completed. The reason is mathematical. A triangle has 3 vertices, and 3 times 4 gives us 12. Now we join all the points marked on the circumference to finally obtain the dodecagon. You will see that another dodecagon remains in the center. We will then repeat the drawing of triangles to fill it in. This process can be continued inward as many times as desired or possible, depending on the size of our drawing. Color the polygon with your favorite colors to finish it. Here are mine. The dodecagon can also be divided with squares, since 4 times 3 equals 12. That is, with squares repeated circularly 3 times. It can also be divided into hexagons. 2 hexagons are enough, since each hexagon has 6 vertices. 2 times 6 gives 12. There are no more factors of 12. So to conclude, we now know that the dodecagon can only have triangles, squares, and/or hexagons inscribed within its surface. Here, I show you those divisions made in the inner dodecagon. We begin with squares, 3 squares arranged radially, and complete the filling. Now we will divide with hexagons, which are 6-sided figures. Only 2 hexagons fit. 2 times 6 equals 12.
If you enjoyed this video or found it helpful, don't forget to give it a like. Got questions or want me to explain something in more detail? Just drop a comment below. And be sure to subscribe so you don't miss upcoming tutorials. It also really helps me keep making more content. Thanks for watching. See you in the next tutorial.